Alright, so I've created a small Python program that will allow you to animate the data that Simulink generates, so you can get a feel for what's happening in your simulation, in contrast to just looking at the plots and say, hey, this thing looks right. It looks like what I'm doing what I'm asking it to, right? So plots are sometimes difficult to interpret, whereas an animation sort of might connect you perhaps a little better, might help connect you a little better to the actual behavior of the system we're simulating. So the purpose of this video is to show you how to use it, or how to get your Simulink model in a state where you can save the data so you can use it, and then we actually have to get the Python code running. So we'll try to do both those things. So first order of business is to go into your model of your physical system. I call mine Pencraft. Inside here is where your interpreted MATLAB function is, your integrator. Here's where we pull in the control signal and let out the state and all that good stuff. Anyway, there's this block in Simulink that you can get. It's where it's in the sinks, I believe. It says to workspace, so right there, to workspace, and drop that block here. And what you want to do is you want to pull the signal off of this input to your interpreted MATLAB function. It's because this one has both the state and the control in it. So we're animating both the state and the control. So there's 10 different signals in there, 8 for the state, 2 for the control. So we want to pull that to the to workspace block. Let's double click on this thing. And you want to name this thing as I've done it here. So the name should be state_u, everything lowercase. It has to be that name because another a MATLAB function has to recognize that. And also in this, you have to select the save format as an array. It gives you some other choices here, but we want the array format. And we also want, when you select the array, it also has another option here. And we want to choose 2D array, concatenate along the first dimension. I'm not sure what it means by concatenate along the first dimension, but nonetheless, this is what we want. Okay, so get that set up. That's the first thing. Now, when you run your Simulink model, what you should find, and you can see it in your workspace over here. So if I look at the workspace, it will create something called out. There it is right there, out. It's a structure. It's the thing that gets generated by this to workspace thing, and that structure holds the data in it. And it's not something that our Python code can read directly. So we have I've created another MATLAB function that will read that thing and save it as a file. So there's another file I'm giving you. It's called expout. And expout is this function right here. It has 2 inputs. One is the out file. The out file is this thing I just pointed you to, this thing called out. And the other is the file name that you want to call your function. So if you don't give it a file name in which you save the data from your simulation, it will choose the file name pcraftdet.txt. Again, you can change this if you want, but it's by specifying a file name. So let me show you how to do this. Let me see. I'm going to have to shrink this so I can fit the command window in view of this video. Looks like I've used it a few times recently. So if you just say expout, so I'm in the workspace now. So if I just say expout and just give it the out argument, what it will do, I can hit the enter, and it did its job. And what that will do is it will create within the folder that you're working in a file called, there it is, pcraftdat, and it's a text document. So it's pcraftdat.txt. So it's creating that thing, right? If you want to give that file a different name, what can you do? I'm back in the MATLAB command window. I can say exp out, and I can give it the file name here. I have to put it in single quotes, so I can call it pcraftdat2.txt if I want to. Okay, so that'll save another one. So let me hit the enter key on that. And we'll see that this created, where is it? pcraftdat2 right there. So I just created that one. And by the way, I didn't mention it before, but that exp out function, that has to be in that folder that you're working in. It's your active, it's called the current folder, I guess that's what they call it. So this function also has to be in there. Okay, so that's how you generate the data from Simulink, put it in your workspace. Yeah, and when you do that, what does it do? Where is this? Well, I'll take this one. If I were to open that, so let's open it with the notepad. It's a very simple editor right here. You can see a boatload of data, right? So this is the data that's being generated by Simulink, and this is what we want our Python code to read so that it can animate that data. Right, so that's the idea here. Let me close this for now. All right, so the next thing we're going to do is get that Python code and run it. So there's two ways of running it, and one way, at least in my opinion, is the easy way, and that is to run it directly on your own computer. The problem with that is that to do that, if you don't use Python, don't have Python, you'll have to install Python to do it. And Python's no small little thing. It's a big language with lots of other packages. So if you're short on disk space and you have no other use for Python, you might not want to do it. And I understand. So for those of you, there's a second way to do it. You can run Python in a browser with this thing called the Google Colab project, and I'll show you how to do that in a second video. So in the rest of this video, I'm going to show you how to do it on your own machine, although some of the stuff that I'm showing in this video will be completely relevant to the other case as well. So if you're going to be running it in the browser, I'm going to suggest you do it. I'm going to suggest you watch the rest of this video along with it. All right, so if you want to install Python on your own computer and you do not have it, I would recommend using the Anaconda distribution. It's spelled like the snake, A-N-A-C-O-N-D-A, Anaconda. You can just Google it, and it's a really nice version of, I shouldn't say, it's a really nice Python package. It comes with all the necessary things. So in this case, if I were to, so I recommend that one. So you're going to have to install Anaconda or some other version, maybe a lighter version of Python if you don't have one already. And then you're going to have to download my Python program. It's called pcraftanim.py. It's this one right here. That's the Python code. And what I'm going to do is I'm going to open it up when in Notepad. There are more sort of sophisticated ways of doing this, but this is the bare bones way. So here it is in Notepad. This thing is going to need the matplotlib library and also the NumPy library. It's as shown right here. If you got Anaconda, then both of those are in the package already. If you've got some other version, my guess is you still have Matplotlib and NumPy, since they are very widely and often used packages for MATLAB. Not for MATLAB, for Python. Cool. So once you have this open, the next thing I'm going to have you do is you might have to make some changes, small changes to this file. And for the first thing that's important is your states. Let me go back to Simulink first. So here's the Simulink model. Remember, we got that data from Simulink from right here, right? We had this 2 workspace block that when we pulled off the input to that block directly from this signal, which is also the input to the interpreted function. Remember, this thing has 8 signals in it. Excuse me, 10 signals, 8 corresponding to the state and 2 corresponding to the control inputs. And those states and the control inputs come in a specific order. So when I wrote this Python code, let's bring it back here. When I wrote this Python code, I assumed that those states were in a particular order, and you can see it right here. So the first thing is time. Don't worry about that. That's getting that automatically. But the states, I'm assuming you're coming in the order listed right here. So I'm assuming the first state is called the X. The next one is your X dot, XX. This is what you might call XG, but it's a horizontal component of your spookcraft, the craft center of mass. So they go in the order X, X dot, Y, Y dot, Phi, Phi dot, theta, and theta dot. Right? So those are the 8 states. And then your 2 control inputs, the force on the left thruster and the force on the right thruster, in that order. So if any of these things are in a different order, you're going to have to change this around, and it should be in the obvious way. So if you put your thetas before your phis, you just have to, I guess, change the sequence, change the order of the sequence here. So you'll have to make that change to this file in order to get it to work. Cool. Now there's another change, I'll talk about that later, that you might want to do, but we'll discuss that later. So let me clear that out of the way. Next thing we need to do is run the Python script. So this particular Python script is designed to be run from the shell. So in order to do that, you're going to have to open up a shell. If you got Anaconda, the new versions of Anaconda have a shell along with it, And the newest version of Anaconda I got for my new machine here, it almost requires you to use the Anaconda shell, which I'm not really happy with, but it works. So anyway, you open up to your Anaconda distribution. And I like to, of these choices I have, I like to use something called the Anaconda PowerShell prompt. There's also the Anaconda prompt, but the PowerShell prompt has a Linux-like interface or Unix-like interface, which I prefer, but you might prefer the other. But anyway, you get a screen that looks kind of like this. That'll take you to some sort of base directory that you have, and you have to navigate to the current folder where your data are located, your data file is located. So the way you move around, or way to look, let's look where we are first. So if I do ls, I can see where I am. That sort of lists the contents of the current folder. And I think I can move up and down here. Well, I thought I could. There, if I could scroll with my mouse, I can look around, and there's some stuff in here, and so my stuff is in this folder called Documents right here. You might have your stuff saved someplace else. You might have it, for example, saved on the desktop. Is that an option? Yeah, desktop is there. I don't like saving stuff on the desktop, but I know some people do. But anyway, let's move over to the documents folder. So to move over, you type CD for change directory, and then you type documents. And now I'm in the documents folder. You can see it listed there. And if I type ls again, that lists the contents of the current directory. And you can see where to go. So for mine, I've got stuff inside my folder called current courses. So I say CD current courses. Notice if I don't have to type in the whole thing. If I hit the tab key, it'll sort of, oops, that wasn't the tab, that's a cap lock. If I hit the tabs, it'll complete that for me, current courses. And after that, it's in a folder called MEE421. And if I hit tab, I only have one 421 folder, so SP20, so it completed that for me. And then I have a folder called projects, I think. So let me tab, it finished it for me, project. And then there's sim. I think that's my so-called current folder. So now I'm in there. If I type ls, it does all the stuff there. And you can see pcraftanim.py. It's right there. And that's what I'm expecting. Right, where'd it go? pcraftanim.py. So now I can run that. All I have to do is say Python, Python, and then I can see pcraftanim.py, and it should run. There it is. So now it's running that data file that we just generated. You might notice that it's running it very slowly, right? It's not running the thing in real time. So if it's going really slowly like it is right now, you can speed it up. And depending upon how fast your machine is and what you got going on your machine, it could be running at a different speed. So let me just get out of this animation. I'm going to just sort of click on the X up here. So I've ended the program. So I want to run this thing again. By the way, if I just run this pcraftanim.py as we just did, it uses the default file name that we chose. Remember, the default file name was pcraftdat.txt. So that's the file it's actually reading from and generating the animation from. If I wanted to generate the animation from this other file, I'll show you how to do that in a minute. But we want to work on the speed first. So pcraftanim.py, and this is why I like working from the command line. I can use command line arguments. So if I put a -s, that adjusts the speed. And if I put a 4 here, I think 4 is about right for me. Maybe 5 would be better. Let's use a 5. I don't know. You can experiment with this a bit. And what that means, it's going to be running the animation 5 times faster than what we just saw. Okay, so when I do this again, you can see it's more active right now. Yeah, it's closer to real time. Right, so this is that simulation we just ran, and pretty soon it's going to get there it goes. You got the reference signal, so it's moving the craft over to a new place, right? So there's your animation. That's how it works. Let me kill that thing. If I want to run the animation from the other file, I can do the same thing. And then I'd use a -f and then put the file name. So what was it called? pcraftdat. And I might roll off the end of the screen here. pcraftdat2, right? And I can hit the tab key again, and it should complete it for me. pcraft2.txt, it's sort of off the recording screen there. And it goes over to the other side. But that's how, it's the -f option that'll allow you to file completely, or to choose your own file. And remember, this file data was the exact same as the file data from the other one, so it's showing the same thing actually. But that's it. That's all it is to run it. If you are using Python on your own machine, so it's slick. Oh, there's one other thing I wanted to show you. So let me kill this. So you might run a simulation. Let me keep it up there for a second. You might run a solution where the little pendulum craft is doing something a little more aggressive. Maybe it's sort of flying off the screen for a little bit and then coming back on. You can change the plot limits on this window if you want. So I've chosen plot limits which will allow you to see sort of reasonably gentle maneuvers like the one we just saw. All right. If you want to change those plot limits, you're welcome to. You can do it. It's no problem. It's really easy, actually. So let me kill this. The way you do it is you go back to this Python script you have, and this is where we perhaps changed it to change the order of those states. If you go down a little bit further, where is it? Somewhere in here. I hope I didn't pass it. There it is, right there. So I've got AX min, AX max, AY min, AY max. So the AX min is the coordinates of the left edge. Right now it's set to -10. AX max is the coordinate, the x coordinate, the horizontal coordinate of the right edge. AY min, AY max, those are the bottom edge and top edge respectively. So everything's set to it -10 to 10, both in the X and the Y. But if you wanted to change it, you're welcome to. You can change that number and then rerun the animation, and it should update that. So it's really simple to do. Cool. So that's how you run it on your own machine. I'll have another video hopefully soon that'll show you how to do it within the web browser using computers at Google, actually, to generate this thing for you. All right, so over and out for this video.